In today's video, I'll be explaining in details the two types of solar charge controller, the PWM solar charge controller and the mppt solar charge controller. After watching this video, you can decide which solar charge controller is best for you. So on the board, if you can see very well, the board is being segmented into two. The left side is the mppt, while on the right side is PWM solar charge controller. So the details I'll be giving you today is one, the configuration of your solar panel using mppt solar charge controller and the configuration of your solar panels when using the PWM solar charge controller. Secondly, I'll be telling you what region or which region is supposed to use the PWM and which region is supposed to use the mppt, and what type of installation or what size of installation is supposed to use the mppt and what size of installation is supposed to use the PWM solar charge controller. So starting from the panel configuration, if you can see the panel configuration here, assuming we have a 350 watt, that's 4 units of 350 watt. If we want to use an mppt solar charge controller, we can do a connection that is in para series. This very one, it means we are using 24 volt battery. That means 2 units of 12 volt batteries. And this solar charge controller is 60 amps. So if we are using 4 units of 350 watt solar panels, what is the best connection to do? You can do two types of connection on the mppt using this 4 units of solar panels. The first connection is parallel, which you have to connect everything together, positive to positive, negative to negative, all the negative of the 4 panels connected together and all the positive of the 4 panels connected together. That is in parallel. Then you can do it in series. So that is why if you see here, I say para series, because we have 3 types of connection: the series connection, the parallel connection, and the para series connection. So if you are using an mppt solar charge controller, like I said, you can carry out 2 types of connection, the parallel or the para series. So I decided to do the para series. So the first 2 are connected in series. These 2 are connected in series, everything wired in parallel. Our total voltage is 84 volts. Our current generated by these 4 panels with this para series connection will be 19 amps. Remember, no matter the type of charge controller, whether mppt, whether PWM, your solar charge controller will allow 80% of the power generated by your solar panels to pass. So if our total amps is 19 amps and mppt allow 80% to pass, we will have 15.2 amps. This is not where the mppt starts its work. This is where the mppt starts its work, which is extra energy conversion. And most mppt does energy conversion from 5 to 21% efficiency, or 5 to 21% energy conversion. So if this mppt solar charge controller we convert 21% of 84 volts, we will have 17.6 amps. So 17.6 amps plus 15.2 amps, you will get 32.4 amps coming to your battery when the mppt do the energy conversion. That is what you get at the end of the day. Coming back to the PWM solar charge controller, where most of the installers are confused, where everybody is confused and everybody will be like, PWM is trash, PWM doesn't work, is in the panel configuration. A lot of people don't understand how the PWM works. And this guy you are seeing here is saving a lot of assets, because most people don't understand how to use this. So many people are falling back to this, because when you come back to this can tell you, give me whatever voltage you want to give me, but it shouldn't exceed my input voltage limit. That is why it's saving a lot of people. Coming back to the PWM will tell you you have to be very careful when you want to use me, because for example, since we are using a 24 volt system and we have 2 units of 12 volt batteries, if we are using a 350 watt solar panel, because there are some panels that actually are short in voltage. So if you use any panel for this configuration, remember that the float charge is 28.5. If your panel is producing 32 volts and you want to use it on a PWM solar charge controller, you will end up not getting results, because the remaining voltage will not push the current so that your battery will get to a float charge or absorb charge. So make sure if you are using a PWM solar charge controller and for a 24 volt system, the voltage should be a bit higher than the battery volt. So since our panel is producing 42 volt, we are fine to go. Coming back to the PWM, which type of connection should I do? when you are using 4 units of 350 watts, the same as this, we want to do the same configuration we did here on the MPPT side on the PWM. But the configuration of the panel will be different from this. So coming back to the PWM, you can only do one type of connection, which is the parallel connection. If you change any other connection here, it means your battery will not charge. So coming back to the PWM, you have to connect all the 4 panels together, all the positive in one place and all the negative in one place. So if you carry out your configuration that way, your total voltage coming from your solar panel will be 42 volts, while your total current will be 38 amps. Like I told you guys earlier, no matter the type of charge controller, it will only allow 80% of the total energy generated by your solar panels to pass. So if it will allow 80% when our battery is low, it will allow 30.4 amps. That is what it will allow, 30.4 amps. So what is the difference between 30.4 amps and 32.4 amps? It's just 2. So I'll ask you one question. Should I now spend over $100 and something in getting this 60 amp mppt solar charge controller for just 2 units of batteries and 4 units of solar panels? Or should I spend 40 something to 50 something US dollar to buy a PWM solar charge controller, which will serve me? I'm not asking you to make a choice now. It all depends on your strength. If you want to go for the MPPT, fine. If you want to go for the PWM, fine. All you have to understand is how to configure your solar panels, because if you fail in configuration of your solar panel, then you have failed here. So who is supposed to use the MPPT and who is supposed to use the PWM solar charge controller? Research have shown that the MPPT solar charge controller works better in a colder region than the PWM solar charge controller. And we over here in Nigeria, we have a lot of harsh weather. Even in the Harmattan, our sun here is still better than other countries. So people in colder region enjoy MPPT more than those in hotter region. Research have shown that MPPT solar charge controller doesn't work that well in the hotter region because of temperature issues. Why, coming back to the PWM solar charge controller, those in hotter region can use the PWM solar charge controller without stress. That means most part of Nigeria should be using PWM solar charge controller and it will still work fine. Then when it comes to size of installation, if you want to carry out a big installation like 8 batteries and above, then you go for an MPPT solar charge controller. But if you are going for an installation of, let's say, 4 batteries and below, your PWM solar charge controller will still work fine. That is why if you see, I said where to apply this is in a small or medium installation, while this in a big or large installation. But among these two, between PWM and MPPT, which can have the longest lifespan, it's the PWM, because it can endure a high temperature, while this cannot endure some temperatures. And why the MPPT doesn't work well in a hotter region is because as the temperature is increasing, the efficiency is decreasing. Before you go for the 2 types of charge controller, you have to understand your environment, whether you stay in a colder region or you stay in a hotter region, the size of your system. So you take these things into consideration.